My name is Maxime Lamotte, and today I'll be presenting A3, Assisting Android API Migrations Using Code Examples. This work was done while I was a PhD student at Concordia University. I'm currently a postdoc at the University of Waterloo, and I'm soon to be a faculty member at Polytechnique Montreal. This was work in collaborations with Drs. Wei Xiang and Drs. Tsehan Chen at Concordia University in Montreal, Canada. So APIs constantly evolve. If you look at an analog for an API, so an interface for power, let's say, the power plug in 1963 in Europe looked like this. In 2021, it still looks exactly the same. Meanwhile, for Android, the first version was released in 2008, and in 2021, we are now at the 31st version, and many changes have been made, from performance enhancements to overall look and feel enhancements to security modifications. A whole bunch of stuff has changed. API migrations can be problematic. So users can migrate or change from one version to another because they want exclusive features that are only available in the newest version, or maybe they're tied to specific functionality like security APIs that need to be migrated to the newest version to keep working. But anyway, when we are talking about API migrations, what we're talking about is API users changing from one version to another. Here we have an example of an API class resources, which has the API method getColor. This example was taken from the Android API. And originally this only had one parameter, so the int ID. And in a subsequent version, the resource theme parameter was added. So the migration problem centers more around how than what. So if we think of the problem that we had before, the what is quite clear. So the users are told from the Android API documentation they have to add a new parameter. This parameter is a theme. Research has shown that the Android API documentation is quite good, and users should be able to easily find what to migrate. The problem is, where do you get this theme, and how do you maintain your existing functionality? So users still have a hard time understanding how to migrate, even when they have this what information. But if you look at a user example, this example specifically is actually quite easy. You just have to put null as a parameter instead of theme, and you get to keep your original getColor method having the exact same functionality. So how can we use this information to help users? So our idea, A3, is to mine existing migration examples from open source projects that know how to migrate, and then use these examples to help API users that don't know how to migrate. So the first step is to learn these API migration patterns from code examples. So first, we have to extract APIs from the actual APIs. So extract the methods and the classes that belong to this API. So this can be done through the documentation. In the case of Android, the documentation is quite good, as previously mentioned, or it could be done using other tools that exist to do this. Once you have a list of the existing APIs, the API methods and classes, then you can search for API calls in user projects, for example, on GitHub. And then if you identify API calls on these projects, you can then search for changes to these API calls in the user projects to see if they've migrated them. If they have, you can save a before and after snapshot of each of them, and that can then be used to help users. So once you have these learned API migration patterns, to apply them to user projects, we follow 4 steps. So the first step is some simple text matching. So we look through the user projects and see if they're using any method that resembles the text of an API call that we have a migration for. If they do, then we construct the control and data flow for their project. So if we didn't do the text matching, we'd have to do the control and data flow for everything, and that would take extra time. So that's why we originally do the text matching. Then once we have the control and data flow, we compare it to our existing learned API migration patterns, and we determine a migration mapping. So if we can determine a migration mapping, we apply the after migration candidate to the user code. Here's a quick makeshift example. So if we have a new version of Android and a user that's stuck using an older version, and we can identify a usage of an old version of the Android API that resembles the users, that also happens to have a migration that's present on GitHub, for example, if we can actually make sure that the old usage is similar to our users project, then we should be able to use the new or after migration code to help the user to migrate. And then they would be able to use the newest version. So in practice, what this looks like is if we have a before and after snapshot of a migration on GitHub, we can then, as previously mentioned, construct the ASTs, construct the control flow and data flow of the before and after migration examples. And we can then compare the user's code to the before migration example. If the migration example matches after we remove nodes that are not necessary, then we can go ahead and do the migration. So here we've removed the text for clarity for the presentation, but we don't actually remove this information for the actual approach. So once we have the original matching, we then construct the mapping between the before and after migration examples. We can then get rid of our examples and use this mapping on the user's code. Once the mapping has been done, the user code gets migrated to the newest version, and the user can then use their application using the newest version of the API. So we got our data mostly from F-Droid, which is a sample of free open source Android applications. But we also looked at the Google Samples project, and we asked some users to generate examples to see if it was easy or not for users to generate these examples by themselves. So our first step was to manually identify potential API migrations to see if our tool could identify them in the wild. So we manually identified 262 potential API migrations in the versions between 16 and 26 of the Android API. And then we run our tool on the sample previously shown. So our approach managed to find 82 potential migration patterns in F-Droid. So these are 82 unique migration patterns out of the 262. Some of these 82 had multiple different usages. And 79 of these 82 were manually determined to be correct. The other 3 were refactorings that were misidentified by our tool as migrations. In the Google Samples project, our tool managed to find 10 migration patterns, and all of them were manually determined to be correct. So most of the examples that we found were considered hard to migrate automatically by prior research. So 45 of them were hard, 17 were medium, and 18 would have been easy to migrate. So this shows that our tool can actually be useful, in at least very useful, for these 45 hard problems. We then run our tool to automatically migrate 32 F-Droid apps. These 32 F-Droid apps were sampled specifically because they had test suites. And we used our tool to migrate 80 API calls in these apps. We migrate the calls and then run the tests. And if the tests pass, we also run the apps just to make sure that we actually target the functionality specifically, because sometimes the test may not target the API functionality that we are migrating. We make sure to do that when we manually run the app after the migration, just as a safety. So our approach can provide aid in the majority of cases. So in 71 out of the 80 cases that we migrated, we were able to provide some kind of help. In 14 of the cases, we were able to faultlessly automatically migrate. In 21 of the cases, there were minor code changes that had to be done. So some renaming of variables had to be done. And in 36 cases, although we couldn't fully automate the migration, we could provide some examples for the users, which they could then use to migrate, and they would not have been able to identify those examples without some severe digging of their own. We also ran a user study for our tool, and participants were 29% faster at migration with our tool than without our tool, and users ranked our tool an average of 4.3 out of 5 on a usefulness scale. Thank you for listening.
I encourage everybody who is in this session to write their question in the chat message so that I can pose those questions to Maxim. Meanwhile, we have Tim. Thank you for your question. The question is, in the code examples, how do you know what versions of the libraries were used? If incorrect versions were used, the migration would be incorrect.
Right. So that's completely true, and that's actually a very good question. So the way that we look for examples is indeed version agnostic, I guess you could call it that, in the sense that we collect all of the possible migrations for a given, all the possible migration examples for a given API migration, right? So if we know that an API is getting migrated, for example, at some point, and then it gets migrated 3 or 4 times in the future after that, when we mine for examples, we don't actually check the versions, we just collect everything. When we propose our examples to the user, we leave it up to the user to determine which one is the one that would fit for their scenario. So the user does have to have some knowledge of what they want to do, right? So our tool can, in perfect cases, automate the migration fully, but the user still has to agree to accept that migration, right? So it's up to the user to determine if the migration that we're applying is the correct one for the version that they want to migrate to. So let's say there is a migration from Android version 10 to version 11, and there's one from version 11 to version 15. If the user only wants to use version 11, he needs to look at the examples that will migrate it to version 11 and not the one that will migrate it to version 15 and decide to apply that migration. Now, whether the tool will apply it automatically or only provide the examples is kind of up to how well the AST matches and how well the tool can define the mapping. But the idea is it's up to the user.
Okay. So the question from Xiao Wei is it required to have 100% matching between the user project and GitHub projects for adapting the update?
So it's not required to have 100% matching, but the closer the matching, the more we can fully automate the migration. So we do have some small heuristics to try and filter out unneeded lines. Like if there's some lines of code that actually don't affect the AST at all or don't affect the control flow and data flow, we try to like filter those out. But it is possible that like let's say an 80% mapping in some circumstances would not allow us to fully automate the migration. If that's the case, then that's where it either the migration will require some small modifications from the user. So the user will either need to make some modifications, like some tokens might be named improperly, like variable names might be incorrect, something like that. They might need to go and rename some stuff. Or if we can't do the migration at all, if we detect that there's not enough similarity between the two, what we end up doing is giving the examples to the user and letting them kind of figure out what everyone else did for their migration.
Okay, there is a follow-up question from Tien. So it says, thanks for the answer. However, when will the interactions with the users occur? That will be complicating your process when human intervention is required.
So the process is always the same in our case. So whether the user wants to do the migration or not, whether the user accepts our migration or not, what we do is we start by, first of all, the user has to ask for a migration check. So it has to run the tool. If the user runs the tool and the tool detects that there are indeed migrations in our data set that could help migrate the APIs that they are using, then we propose the migrations that exist in our data set. If the user then accepts to have a migration, we attempt it. If it works, perfect. The user can accept the final modified code. Or if it doesn't work, or if we feel like we can't actually proceed with the automation of the migration, then we just give the full example to the user or multiple examples in some cases if we have multiple. and then the user has to kind of look through them as though they were looking on GitHub by themselves, except it's a guided search in the sense that we have found these examples for them, and they don't have to go and dig through GitHub for them by themselves.
Okay, we have a question from Shanduk, and the question is, could you give us an example of a hard case and an example in which the tool cannot automatically migrate API? So in other ways, where your approach somehow is inaccurate or cannot be applied.
Yeah, so the more difference there is between the way a user is using the original version of their API and the way other users were using them on GitHub, let's say, the less likely it is that we can automatically migrate. So, for example, if someone is using an API as a one-off, so let's say they get a color for something, but the example that we have is getting a color and then running a for loop, and then in that for loop modifying the color somehow, and then at the end using the final color to actually give it back to something else. If those two examples are extremely different in data flow or control flow, we will not be able to make a mapping, even though they're using the same API, and maybe the migration would be like a one-to-one. If the control flow and data flow are completely different, the tool will not attempt it. So we're being a little bit on the safe side here in the sense that if somehow the control flow and data flow could affect the way that the API is being called and used, we don't attempt automatic migration. We just show the examples to the user and say, listen, this is what we have. Maybe you can figure out how to migrate. Maybe it's easy, but we don't want to automate fully here.
So we have two remaining questions. I don't know if we'll be able to answer both. So the first question is from Sridhar, and is what strategies did you use to match with code examples?
So the first strategy that we do is very, very naive. So it's just a text matching. So the very first thing that we do, we know you're using, again, let's go back to get color API. We just do a text matching for whether sample projects are using get color. Now, we also check to make sure they're using the proper get color in the sense that they're not defining their own get color method and we're not mistaking a user defined method for an API call. So we do check imports and that kind of stuff, but it's just a like very rough text matching. Once we do this, then we start extracting the AST from the example if there was a matching. First of all, like the text matching has to happen. Then we create an AST, we create control flow and data flow graphs, and then we map the control flow and data flow and the AST as much as possible. Depending on how we match, then that's when we decide whether we have a good mapping or not.
Okay, we have the last question from Malinda, I guess. The question is, what is your opinion on extending this tool to dynamically typed languages?
It would be hard. That's my opinion. So I don't know that it would be impossible, but I think the problem is you have to start inferring a lot of things, right? You have to start using a lot of inference for a lot of variables and a lot of. I don't think it's impossible, but you might have to create circumstances that are a lot more rigid. So the code might basically start looking like code clones at that point, like exact clones where you can say, okay, they're using exactly the same way that we are. And so at that point, if we can say it's like, I don't know, a 95% clone mapping or above, just a random threshold, then the chance and we'll try to do the migration if they did it ahead of us. But I think you'd have to be a lot more rigid than what we were for this tool.
All right, so thank you again, Maxime. Thanks, everybody. So the conversation will shut down in 3 seconds. If you're interested, please follow us in the pop-up button.
Thank you.
Okay, so Maxime, now in a few seconds, we will have a pop-up button on the bottom right.